Okay, so in case you missed it on Friday, we are starting our lesson on trig. Now, as far as this section goes, it is important that you guys have a calculator or something to do trig with. Now, if you want to use your phone when you're doing this, I'm okay with that. But if you need a calculator, I'll pass those out in just a minute. Now, I want to recap a couple of ideas because on Friday, we had talked a lot about our three different trig ratios: sine, cosine, and tangent. I wrote a few things on the board off to the side so that you guys can get those copies down. If you weren't here on Friday, then there were notes. I will have them posted on Canvas along with this next assignment. Which is what I'm passing out to you guys right now. And I'll also post the notes from today as well. But the notes from yesterday were the majority of what's needed for this section. We're just going to do a couple other examples, and then we're going to take a look at the worksheet that I'm passing out to you guys now. Any questions before we get started? Also, for this section, so we're going to spend a few days on this. Today, we're going to finish up the notes. Tomorrow, we're probably going to spend a little bit more time just solving basic trig problems. Wednesday, we'll finish the last section where we're doing more with word problems. And then I'm thinking we'll probably end up testing on Friday. So Thursday will probably be review, and Friday will probably be test. I haven't decided that for sure yet. I just want to see how the next couple of days go. So, but there's a good chance that Friday could be a test. All right. So, starting off with this problem, we have an angle given to us and two sides. All right. So right now, this angle, we have a 30-degree angle there in that corner. We have 8 is our hypotenuse, and then we have a side that's x and a side that's y. Well, first thing we need to do is label all those other pieces. So on this triangle, we have our hypotenuse, where the 8 is. We have x is across from 30. That makes that our opposite side on this one. And then y, that's next to the 30, so that's our adjacent side. Again, when we talk about opposite and adjacent here, we're talking about the two legs, right? So the opposite leg is the one across from the 30, the adjacent is the one next to 30. But it all has to do based off of this angle. Now, if we have both of the two angles labeled, then you have to pick an angle in order to solve. In order to solve for x, right, here we're using the opposite side, and then we also have a number as hypotenuse. We're going to use the hypotenuse each time. If you aren't sure where to start, you should always, I'd say, always start off by writing out SOHCAHTOA. And just to remind you guys what SOHCAHTOA is, first one way to remember it was the saying I said: some old hippie caught another hippie tripping on acid. So we spelled it out, SOHCAHTOA. What does it stand for? Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. So we have our setup. Coming back up here. So again, we're starting off for x. X is opposite, 8 is our hypotenuse. Which one uses opposite and hypotenuse? So sine, right? So sine of our angle measure is equal to the opposite, x, over the hypotenuse, which is 8. So sine of 30 equals x over 8. Now, we are going to solve this equation. So what are we solving for? Well, we're solving for x. In order to get x by itself, we need to get 8 over to the other side. Currently, 8 is being divided. So what's the opposite dividing? Multiply. So we're going to multiply both sides by 8. On this side, we now have 8 times sine of 30. On the other side, if I multiply that by 8, 8 cancels out, and we just have x. So now, this is the part that we have to actually plug into the calculator. So if you have a calculator, take it out. If you don't have a calculator, I'll walk around with some real quick. Yeah. You can also use your phone. Yeah, again, when it comes time for the tests, of course, you're gonna have to use your calculator, but your phones work pretty much the same way these calculators do, so. And again, if you're using a phone, you're most likely gonna have to turn it sideways so you get all the extra features, all those extra buttons. Because the 3 buttons that you need are sine, cosine, and tangent. So, all right, on this one, we're just plugging this in now. Now, how do you plug it in? Well, I highly recommend that you do the sine part first. So on most of your calculators, you're gonna be typing 30, then sine, it's gonna give you a big decimal, and then times 8. Some of your calculators, you might be able to type the whole thing in before you hit enter. So some of you might be able to type it in the order that appears. Just depends on what calculator you're using. So you should get familiar with different calculators so that you know how to type it in. But if you have one that's a single line, something like this, it's at 30, then hit sine, and hit 8. And that has a multi-view screen. This one, or this one, then you can type it in as it appears. Right? So most of the phones, kind of like this one, you're better off setting 30, then sine, and then times it by 8. So if I did 30 sine, just so you know, we should get 8 times 0.5. Multiply that out, so times 8 is 4. Now, are you always going to get nice whole numbers like that? Most of the time, you won't. All right. The only reason why I've got a nice whole number for this one is because I showed you the special electronics. We'll take a look at rounding on some of the other problems. So, on this one, we've got x. Oops, my hand is put forward there. Oh, I'm not quite using my test report right now. There we go. So we got our x, we need y. So now let's switch this color. We have y over here. We're still using the same angle, but now we're solving for y. Do I have to change the way they're labeled? No, because I'm using the same angle. Now, if I had switched the angle in the problem, then I'd have to relabel it. But for this one, since I'm keeping the same angle, we can keep everything labeled the same way. Everything's labeled based off the angle, not based off the side we're solving for, but based off the angle. So now I'm solving for y, which is the adjacent side. So let's say I use adjacent and hypotenuse. Well, which one of these is adjacent and hypotenuse? Cosine. So we have cosine, still of that same angle 30, is equal to adjacent, which adjacent over there is what? Hypotenuse is. Now, if I wanted to, since we had already solved for x, could I use x instead? So since we solved for this side, we know that side's 4. Could I use that side instead to solve? Yeah, if I use that side, it would be opposite and adjacent, and I would use tangent. You get the same answer either way. So we got our setup. We're solving for y. We got to get 8 over to the other side. So when we did here, multiply it over. So 8 times cosine of 30 equals y. Again, plug it into your calculator. When you plug it in, 8 times, let's see, cosine of 30. That one comes out to decimal, so 0.866. Approximate symbols. Now, do I want to take that and retype it into my calculator and then multiply by 8? No, I want to keep that number in the calculator. Right? There's no reason to retype that, because if you retype it, you're losing decimals. If you're losing decimals, then your answer could end up being off by a little bit in the end. You don't really want to round unless you have to, right? So we have it 0.866. That's in the calculator with a bunch of other decimals. Take that and multiply it by 8 times 8, and you get 6.92823. Now, I didn't say what to round to. Most of the time in a section, they will tell you what to round to. If they say round to the 10th place, how many decimals would that be? 10th place would be 1. 100th place would be 2. 1000th place would be 3. Easy way to remember that. Yeah, how many zeros are, right? If we're rounding to the 10th place, there's 1 0 and 10. You're rounding to 1 decimal place. If we're rounding to the 100th place, it's 2 zeros and 100. You're rounding 2 decimal places. 1000th place, 3 zeros, 3 decimal places. All right. So let's say we round to the 100th place. So round to 2 decimals. What would our final answer here be? 0.923. Because this value is greater than 5. We had to round that one up. So that's our final answer for y if we round it to the 100th place. Any questions there? All right, now we're going to move on to the sheet that I passed out to you. So, all right. So now we're on that other paper. I think this is like page 23. No, 24. All right. So on page 24, it's kind of a little bit of a recap of what we did in our notes, but it just looks a little bit more confusing. So again, I wanted you to get in your own notes so that they were labeled a little bit better. But again, there is a recap there of what we did. Now, this is all about setting up ratios, which we're going to take another look at. So on number 1 here, I want to take a look at setting up some of these ratios. So for this first one, we are finding ratios of sine, cosine, and tangent of both of these acute angles. So we'll be doing sine of J, cosine of J, and tangent of J. And what's the first thing that we should do? Label them. So how do I label these? All right, so this is going to be a hypotenuse no matter what. All right. Then what? Where am I going from? I got to go from J now. So I have to look at what angle we're using, which we're using J in each of these. Now, based on that angle, I need to label the other 2 pieces. So what 2 pieces are these? Let's start with the 16. 16 is the adjacent because it's next to J. So 12 is our opposite because it's across from J. Yeah, that's for J. So plug these in. Again, if you forget your which one's which, sine, cosine, tangent, write out the same. Some old hippie taught another hippie tripping on acid. And we have sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Now we have a visual as to what we should be saying up. Sine is over h, so opposite over hypotenuse. That's going to be 12 over 20. Can I reduce that? Yeah, they're both divisible by 4, so that'd be 3 over 5. What about cosine? What's cosine? So you're right, it is adjacent over hypotenuse, it's A over H, so adjacent over hypotenuse, which is 16 over 20. What does that reduce to? 5. All right, now we have tangent of J. All right, so going off of J, tangent, what are we doing? So over A, opposite over adjacent, what's the numbers? 12 over 16. Again, that also reduces by 4, 2. 3 over. All right. So we have answers. Is that all they wanted us to do? What the directions tell us to do? We always want to make sure you read the directions on this. This one said it wants it as a fraction and as a decimal. So these ones we actually get as whole numbers. 3 over 5, sorry, not whole numbers. We get its exact value. We don't have to round. So 3 over 5 reduces to 0.6. 4 over 5 reduces to 0.8. 3 over 4 reduces to 0.75. That's it. If we need to round to the nearest hundredth, we didn't have to round on any. So we got all of J. So now what do we do? Got J. It wanted both J and L. So now we need the sine of L, the cosine of L, and the tangent of L. If I go up to the figure, do I leave everything the same? No. So what does stay the same? Hypotenuse, because the hypotenuse is across the right angle no matter what. So this is still our hypotenuse. But the other two, they switch. Now for L, this is going to be opposite. And this is going to be adjacent. Because based on this angle, L, this is next to L, this is across from L, next to is adjacent, across from is opposite. So, setting these up. Now, I have it labeled. We can do it same way that we did the last one. Sine of L, opposite, over hypotenuse. 16 over 20. There is a faster way to do this right now. A faster way? What could we do instead? Going back to and looking at that figure again. Something that we done on Friday. That pattern. So sine of J and cosine of L should be the same. Cosine of J and sine of L should be the same, which we can already see those two were the same because they're in the same triangle, which makes them complements. And the sine of one angle is equal to the cosine of its complement. So instead of redoing all this, hey, we already have our final answer. It's 3 over 5 and 0.6. On this one, it's 3 over, oh, wait. Can I just take tangent? So on this one, tangents, they're not going to be the same, they're going to be reciprocal. So this is 3 over 4, this one's 4 over 3, which reduces to 1.3 continuous. We round it to do 2 decimal places like the direction said, 1.33. All right, number 2, if you tried it, it's going to give you the exact same values. Anybody know why it gives you the exact same values that we got on the first one? It is a triple. They're both triples. What triple are both of these? 3, 4, 5. Both 1 and 2 are 3, 4, 5. This one's just multiplied by 4. This one's multiplied by 8. But if they're similar figures, the ratios would have to be equal. So if we did number 2, all our values should end up working out to be the exact same things. So we can go ahead and skip number 2 for right now. Let's come over here to number 3. There are a couple on this one I want to take a look at because, and we're just going to do J. But the reason why I want to look at this is because we have these radicals. Now, I'm not going to try to give you a lot of problems that have radicals in it like this, but again, we are going to use radicals in other situations, and we do need to know how to simplify when it comes to radicals. So on this one, you do have a few that are a little bit tricky when setting this up. Again, I won't make it this challenging on a test, but looking at sine J, cosine J, and tangent J on this triangle. Our parts, again, hypotenuse, always label that first. Now, based on J, which side is that? Well, radical 3 is adjacent. 36 is opposite. So, sine J, cosine J, and tangent J. Sine J, well, sine opposite over hypotenuse. So that's what? 36 over 24 radical 3. All right, cosine J. All right, and tangent of J. So, tangent, again, opposite over adjacent. So we got opposite of 36, adjacent was 12 around 3. Now, can we leave a radical in the denominator? Yeah. And I showed you guys how you can do what you call from algebra, rationalize the denominator. If we want to rationalize the denominator, we can go through those steps to get rid of our radical in this case. But I did share a pattern with you guys that is always true. If we divide by a square root, we're going to end up dividing by what's underneath the radical and multiplying by the exact same amount. So here we have, we're dividing by square root of 3. So what's going to happen? What's 36 divided by 3? What was it? 36 divided by 3? What? Yeah. And then multiply by that same radical. So now I have the radical on top. Now I can still simplify this, but I follow that same pattern that we had before. Divided by what was under the radical and multiplied it to the top. And I actually have the work over here from last year. It's the same problem. Yeah. So what did you do? Well, you have this. In order to get rid of a radical, you multiply by the same value. But if you do something to the bottom, you also do it to the top. So then it became this. Square root of 3 times square root of 3 is just 3. And then those two reduce and give you that. Again, lots of extra steps. It's that same pattern every time. Divide by what's in the radical, multiply by the same radical. At that point, you could reduce it a little bit further. 12 and 24, you go into each other. That just becomes 3 over 2. So that reduces to 1, that reduces to 2. The next one. This one's even easier. Square root of 3 is on top and bottom. What's going to happen to square root of 3? Cancel that. Now we have 12 over 24. That reduces to 1 half. On the next one, same idea as the top one. Well, get rid of the radical 3. We can divide 36 by 3, 12. Multiply by the same radical. Now we have 12 over 12. Those cancel out. And we just have square root of 3. Let's flip this over and look at the back. Just a minute. Pretty good. All right. So then on the other side, we have our trig ratios. This time they're using them to solve for angle measures. Whenever we're solving for an angle measure, we're going to have to use the inverse operation. We're now getting into solving for missing pieces. So whether it's angles or sides, we're going to have to use a calculator. If we are solving for an angle, then you're going to have to use the inverse operation on your calculator. If we're doing a side, then you just use the regular operation on the calculator. So we're going to look at the first two. Now, some of these do have radicals in them. Nope, shouldn't make any different. Again, it might take a little bit longer to plug into the calculator, but that's fine. Number one, you have 14 radical 3 and 34. They want us to solve for angle T, it says in the directions. So this is the angle we're using. Based on angle T, what two parts do I have? Do I have a hypotenuse this time? What two parts do I have? Opposite and adjacent. Which one's which? So 34 is our, sorry, 34 is our adjacent. And 14 over 3 is our. Now, which operation uses opposite and adjacent? And if you need to, you can write it out again. Write out SOHCAHTOA. I do have it on the sideboard over there. Opposite and adjacent is tangent. So we're doing tangent of the angle equals opposite over adjacent. Standing from all sides. Knock it out. Paying attention. All right. So on this problem, I have tangent T. I have it set up. We have to get T by itself. How do we cancel off T? What's the opposite operation of T? We did one problem like this last week. The opposite of tangent, sorry, opposite tangent here, you have to do the inverse. For sine, cosine, and tangent, the opposite operation is always the inverse. So if you look at your calculator, you see in blue or green writing maybe above it, you see like the little to the -1 power. That's the opposite operation for those. So on here, we're taking the inverse tangent of both sides. If I take the inverse tangent over here, it's canceling off tangent. So now I just have the inverse tangent on this side of that fraction. Now I need to plug it into the calculator. You're probably going to want to do this a couple steps at a time. All right. I want to do it all at once unless you have a calculator that you can plug in the full equation. So some of your calculators, you might be able to plug in the entire thing in the order it appears. But a lot of them, let's say you're using this one or your phone, you don't want to do this one step at a time. So I would start with the square root of 3. Square root of 3, do that first in your calculator, then multiply by 14. Once you have that piece, divide by 34. Once you have that answer, take the inverse tangent. Your correct answer will be in the 30s. So try it, see what you come up with. I'll write out the answer step by step so you can check your work as you go if you want to. But I don't expect you to normally write out all these steps. Let's see. And I would always recommend never rewriting a decimal, because like this was a much longer decimal. When I wrote it out, I rounded it, but in my calculator, it's still there. Now I'm dividing by 34. I'm not retyping in that other answer because that's going to change my overall value to them. Again, Once I'm there, inverse tangent. So second, inverse tangent. We should get, anybody got an answer in the 30s? 35.49. Now, what do they want us to round to? Here's 10. So if that value was 9, and you round the 4 up, so it's 35.5 for my final answer. And that is in degree because that is an angle measure. Now, if you got all the way up to this step and got the wrong answer, all right, well, there's probably something wrong in your calculator. So let's say instead you got 0.619. Anybody get 0.619? Yeah? All right. Well, what happened? Our calculator was in the wrong mode. So on Friday, I said something about degree and radians. If your calculator says RAD at the top instead of DED, then your answer is going to be wrong every single time. You have to make sure your calculator is in degree mode whenever you're working on this problem. Because once you hit sine, cosine, or tangent on your calculator, if it's in the wrong mode, your answer is going to be wrong. So you have to double check and make sure that on the top it says degree mode before you do anything else. All right. Otherwise, you'll get a wrong answer. All right. Questions so far? Now, most of the time, you won't have a radian in there, so it'll be a little bit easier. I want to do one more example for our sides before I give you any work. We're almost out of time. 10. So, yeah, we got 30 minutes. All right, page 26 is the assignment that I'm going to give you to do. Only 26. Don't do any of the word problems yet. I want to do more practice with this. But I'm going to do number 9 with you real fast in these 3 minutes that we have left. So 36 is our angle. So X would be our opposite side. 7 would be our adjacent. Again, opposite and adjacent, that'd be tangent. We have tangent of 36 equals X over 7. We need to get rid of the 7 by multiplying for both sides. We end up with 7 times tangent of 36. Plug into your calculator. Again, if it's in degree mode, you're just going to do the tangent of 36 first, so 36 tangent, and then you multiply by 7. You should get an answer of 5.085. So we're going to round to 9 because this one said round to nearest 100th place. All right. Try your calculator, see if you come up with the same thing. Any questions? All right. So again, your assignment is just at one page, page 26. Don't do page 28. I don't want to do more problems yet. If you borrow one of my calculators, I'm going to come around with the bin so you can toss it in real fast. It's fine to use your cell phone on assignment tonight and you do the functions. Make sure you turn it sideways. You don't have a calculator. Calculator yourself on sideways. Have some cosine. That one might be. Oh, this one. Thank you. So, all right, first thing, go ahead and take out the notes that you were doing on Friday. If you weren't here on Friday, take out a sheet of paper, take some notes on Friday. We're gonna add to those notes. And if you didn't get them on Friday, I will add those on Canvas tonight along with the assignment for today. So it'll be on that same assignment. So if you missed Friday's notes, you need to have that paper out so that we can finish the notes, because we had, I think, 2 slides left, and then we're gonna go with some problems from the worksheet. Oh, this is we're adding on. And then he said that all right. So firstly, if you have a calculator, great. If you don't have a calculator, then I'm going to come around and hand you one. Again, you can also use your cell phone while we're working on this section, but I highly recommend the use of a calculator so you can get use of it, because on the test you can't use your cell phone, but at home you can. Kevin?